Well, good morning, good afternoon. What else we got? Good night, I suppose. Good evening to anywhere where you may be in our lovely world. Thanks so much for joining us live today for Serverless Office Hours. We are streaming on the AWS Twitch channel, and we are also streaming on the AWS Events YouTube channel. So where you're joining us, thank you very much. I'm Julian Wood. I'm a developer advocate who does more things for serverless with serverless here at AWS, and I'm joined by proper experts. I say this often that we have experts, but this is proper experts, believe me. So first up, Heggy, you've been on Serverless Office Hours before. I think one of the people in AWS who knows more about serverless than anybody I know. So thanks for joining us. For people who don't know you, what's your journey to all the cool things serverless that you do on AWS?
Sure. Yeah, I've been here at Amazon about 8.5 years now. I would say for the majority of that time, I've been doing just AWS native, a lot of serverless back then. And I work with what we call our strategic accounts, which are some of our larger customers. And so really thinking about holistically, how do we not just build, an SQS to Lambda function, but how do we do the full SDLC process in the context of very large organizations? So really happy to be here today and really excited to get into this topic today.
Cool, excellent. Great to have you. And Satish, this is the first time you've been on Serverless Office Hours, so welcome. And what is your journey to what you do at AWS?
Great. Thank you, Julian. Great to be on Serverless Office Hours. And so I look after product management for our application networking services, particularly VPC Lattice. I've been at AWS for just over 3 years now. I come from a pure networking background, writing microcode all the way up to designing big routers and switches at large companies. And then at AWS, it's exciting times to sort of build a very simplified application networking portfolio. So it's keeping us busy, and we're excited to share all the new innovations with you.
Excellent. Well, we are talking about simplified networking today, so that sort of goes in straight what you're talking about. But if people want to keep up to date what's happening on the worlds of serverless, I've sort of got 2 links for you. One is, just basically generally what's new in AWS, and this is a link to the What's New feed, filtered for serverless. So you can see all the new things that are coming out, which is cool. And our compute blog post, that's one of our blog places where you can get all information on sort of our AWS compute services. And there also are various other networking blogs and architecture blogs and things like that, so plenty of blogs that you can also have a look for as well. Also, for people who are either streaming on YouTube or are watching this in the future, our YouTube channel, AWS Events channel, has a whole bunch of the previous episodes as well, so they are there kept for posterity with some lovely show notes. So if you want to get some contact information for Higgy and Satish and myself, they are there as well. So when I started in serverless, one of the things that I loved about serverless was that it actually had very little networking. I also came from an infrastructure background, routers, switches, firewall rules, all the stuff and all the connectivity and IP addresses and subnet masking and all this kind of thing. And one of the great things about serverless and sort of also AWS was a lot of that networking was not just needed. But I also know that was quite naive, because although that is the case, there's still a lot of networking behind the scenes, a lot of private networking that you need to connect to, and obviously lots of different things you need to connect to. So Satish, just over to you. Give us a bit of overview of why networking maybe is important for serverless people.
Yes, absolutely. Yeah, like you mentioned, we have all come from different backgrounds, not purely compute, right? And we get into the serverless world. It's like, hey, what IP is it going to get assigned to? Should the application identity be tied to layer 3, layer 4? But most of my applications are at layer 7 now. That's what I wanted to use Lambda for, or set up an event bridge for processing different applications, talking across accounts, and then step functions to sort of manage the sequence of serverless. So when you speak at that level, then what does networking mean, right? So this is what we're trying to do with Lattice in particular, is to sort of simplify that with having native integrations with Lambda, not having to require a load balancer to invoke it. At the same time, keeping track of, if it doesn't have an IP identity, how do you enforce authentication authorization, right, for security purposes? And then how do you improve the observability when things go wrong without the network and the flow logs and everything else? How do you know where to look, what to look for, what failed? And so then there's the whole the Kubernetes and other side, which most of you don't probably care about, but it's the other piece around. I don't want to manage the instance. I just want to run on a Fargate. So we had native integration with Fargate as well. So you don't have to manage the server, but you still run your whatever your preferred compute type is. And this is particularly relevant on the serverless side because now you don't live in a vacuum, right? You still have to talk back to any EKS services or any containerized orchestration services, or sometimes even native EC2 as well. So that's what we built Lattice for.
Excellent. So we are talking about VPC Lattice today, if you haven't realized. And now, also one of the things I think about with serverless is, one of the superpowers of serverless, and it can be abused, is splitting things into more manageable pieces. And you may call it microservices, or you may call it splitting up your web app and having different Lambda functions, or maybe one Lambda function in different databases. And that is certainly a superpower of serverless. I say it can be abused because you can go way too far and have way too many things to manage, and then it can cause you utter chaos. But of course, as soon as we distribute things, there's a network between the two that needs to connect things. And some of our best practices for scaling and security and this kind of things is also multi-account, which makes everything that slightly bit more complex, and VPC and peering, all this kind of thing. So as you said, you're talking about VPC Lattice. Okay, what's a quick overview of VPC Lattice? Because in my mind, I'm thinking VPC peering, and I've got to add these, connections between all these different VPCs. I've got a trillion different subnets and security groups I need to manage. And already the serverless people are like, I don't even know what a subnet and security group is. And the networking people are going, how many subnets and security groups? So yeah, tell us what's the sort of story of VPC Lattice and what it's there to solve. And just before we do get you, just remember we are live, so send us your questions and comments. Robert Tables is already here. Thanks, he joins us often. Thank you. It's a user classified as layer 8. Robert Tables, for this episode, we're going to have to call you Robert IP Tables, maybe. And Anton, thank you very much for joining us, also one of our serverless experts. And Daniel joining us from Brazil. So yeah, we love to hear where you're from. Our global audience is super interesting. But yeah, Satish, I did interrupt myself. But yeah, VPC Lattice, what are we talking about?
So exactly what you mentioned, right? Like, as in, how do we do this? So I have a quick slide to share.
Yes, certainly.
When we built Lattice, we had these 4 sort of guiding principles, and this was again built for developers, right? So how do we quickly help you, whether you're a serverless developer or a Kubernetes developer, how do you quickly build your business logic without having to worry about networking, which is what our goal was and goal is, and we're building towards it. So the first principle was around just connectivity, as in, you have your Lambdas or your Fargate in different VPCs, wherever they are, or not even have to associate them if you're just going to invoke a Lambda, and Lattice connects them all together. And so this is where, you don't have to worry about IP addresses, because we don't use IPs to route them anymore. It's more like connecting pieces of code that are living in different parts of AWS. Think of it that way. So exactly what serverless did to servers is what Lattice intends to do with networks. So think of it as networkless. Right? So don't have to worry about IPs. You don't have to worry about IPv4 or v6. So that was the first guiding principle around connectivity. The second is to have all compute types natively integrated. So I know I already mentioned Lambda, Event Bridge, step functions, etc. And then on the non-serverless side, we support all of them as well. Kubernetes orchestration, our own ECS orchestration, EC2, on-prem connectivity, etc. And then observability is where we did the biggest, one of the bigger changes is every request that goes over Lattice is logged. So you have a zero trust way of enforcing and authenticating. Doesn't matter where it's coming from. You don't have to do something different for serverless versus non-serverless workload. It's very consistent. And then Lattice is also your load balancer. So you don't have to use like an ALB in front of Lambda today that you have to use to invoke. Lattice can directly invoke Lambda as well. So we see a lot of customers going and deploying various microservice architectures, like Julian mentioned, at scale, and connect them back to other services that they need to. So that's a load balancing piece. The biggest change is around security, right? So again, going back to the traditional network and firewall rules, typically applications were tied to an IP-based identity, layer 3. And then firewalls looked at layer 3 and layer 4-based control. When you say, hey, can this application in this account talk to that application? You have to rely on the IP identity. With Lattice, what we've done is sort of extended the use of IAM for your own service-to-service authentication authorization. So your Lambda or Lambda gets a Lambda role, right? IAM role. You can assume those roles. You can assign each microservice to a unique role. And then you use that role to assign your requests, just like you call AWS APIs, CLI today. And then we use that IAM identity to authenticate you. That's what you get. And then second, we use that IAM policies to sort of enforce authorization. So you can say things now like, hey, let this service be only called from this account or this VPC or from a service in that VPC. For example, you can say things like, hey, only allow this service, my service, to be called by this other Lambda function, and only allow that Lambda function to do a specific HTTP method, for example. So this is very relevant for the AI workloads going forward, where you say, if you're building an MCP server very quickly on a Lambda function, you can have that be controlled by saying, hey, only allow posts, but only allow from this VPC or this account, from this Lambda service or any other service for that matter. So those are the ways in which we are simplifying and building Lattice to be very serverless friendly, at the same time giving you access to all sorts of non-networking constructs that are hidden away, but give you the security, the observability, and the connectivity across your VPCs and accounts as well.
Well, that's great. So I actually like the focus on developers, although that sometimes scares me if I put a networking hat on, because I know sometimes, in big organizations, you say, if you ever said to a big organization, don't worry about your networking, you don't need to worry about networking, developers can just figure it out. The networking people are like, are you insane? So I suppose there's two parts of this, is that the sort of network team can also set up these constructs and set up the security, observability, and all that traffic control. But then it's really built for developers to consume that really easy. So they don't have to know all the networking stuff, but they know that it's all sort of set up centrally to your organization's policies and compliance needs. Is that a way to think of it?
Exactly right. Yeah. So think of it as, the central team sets up the basic constructs in Lattice, as in connecting things around accounts and VPCs. Without needing any networking stuff, right? It's even the network team doesn't have to worry about, hey, what subnet should I connect to? That's not even the question for the networking team. And then when it comes to the developers, it becomes a lot easier, because now all you have to do is, okay, whether you're running in a Lambda function or you're creating a event bridge-based step function sequence with Lambdas or other compute types, that's all you're worried about. And then you say, hey, I'm this service type, I need to invoke this other service. We simplified the service discovery as well. It's a very simple DNS-based service discovery. So if you need to call another function, another service that's running somewhere in a different account in a VPC, you shouldn't care about the subnet, the IP. You just invoke it using the DNS name. And then when things calling your service, you have a way to sort of set up a policy that says, hey, I'm only going to allow access for these types of requests. And this is not network-based control. This is what developers can do through auth policies on their own services themselves. So it's a very simple model.
Yeah, one thing that I want to kind of drill into on what Satish said, that second point around like consistency across compute services, you can almost imagine in your organization that maybe there's one team that really loves to do it on Lambda. Maybe there's another team that really loves to do it on Fargate. Maybe there's a different team that loves to do it on Kubernetes, right? Deploying their applications. So you could have a Spring Boot application. You could deploy them across all three of those compute platforms. And with Lattice, basically, because everything is now exposed as a service, you access those services via a DNS name. You just basically make let's say a curl call against that DNS name. And because Lattice is now interconnecting all of these capabilities, like I'm none the wiser that it happens to be on Lambda, that it happens to be on Fargate, or it even happens to be on Kubernetes. So this now gives your developer teams a lot of freedom to say, we're going to choose what compute platform is appropriate for our team and that maybe our platform engineering teams have enabled for us. But now as a consumer of those APIs, Lattice kind of democratizes that so that everyone can access those with all the security controls that Satish just talked about.
Okay, and then also I suppose migrations. If you move between Kubernetes, ECS, and Lambda, your consumer, they just target the same sort of group or DNS record, and then you could basically swap it out behind the scenes without having to, I suppose that because there's a load balancer built in, that sort of mental model of yes, there's a load balancer, but it's not quite a load balancer. There's a whole bunch more over there, but it makes the sort of moving things around in your organization a little bit easier.
Exactly. Yeah, that's another very common use case that we're seeing with Lattice is refactorization. Right. So you're a developer. you're given an application that might be in a let's say one compute form factor today, and you're either refactoring it into can I refactor into how many different microservices and run them as separate lambdas, for example. Right? So in this slide, I'm showing a very simple way of having an existing service that's running on an autoscaling group, and you can slowly migrate it over to Lambda, for example, right? Or any compute type to any compute type. And so here, the client doesn't have to know about any changes. You don't have to go back to the networking team to sort of set up a separate path to whether you want to call it the blue, green, or the canary in terms of upgrades, et cetera. And the security policy that you put on the service applies to both. So the existing autoscaling group and the Lambda. So you're not introducing any new security vulnerabilities as well. And it's as simple as setting that route path-based rule that I'm showing here to say, hey, start sending 10% to this, moving this function over to Lambda as soon as I'm good with the concurrency, the settings, and the code in the Lambda. I'll leave it there, or I might take that Lambda and refactor it further if it's doing too much. Refactorization is not a one-time thing, as we all know, right? It's an iterative, very involved process where you might have an optimal architecture today, and tomorrow your needs might change, and you might have to refactor it all over again, right? So we made it easier for you to sort of move from one compute type to the other, or refactor further, and have not introduce any networking knowledge or security vulnerabilities.
So also just a slight inverse question. When would you not use VPC Lattice? I mean, this sounds amazing. I'm like, absolutely, I should just have VPC Lattice connecting to everything. Yeah. I'm sure there must be some sort of cutoff point, or, is it once you go to multiple accounts or across various things, or is it a team organizational boundary, or a bit of both? At what stage in your journey of building a serverless application should Lattice come into the picture?
Yeah, that's a great question, Julian. So think of it as when you're connecting east-west traffic, right, across your VPCs and accounts, and then you're either whatever compute types you're in, like Hiki was mentioning earlier, depending on your optimal choice for that particular application, et cetera. And that's where you would start to look at Lattice and go, okay, how do I connect all these VPCs or accounts, or in the serverless world, I have these pieces in this region that need to talk to each other, but then they also need to go to something like a database, for example. Right? How do I get to that database? And then how do I invoke the other services that might be running in non-serverless modes? So that's where you would start to sort of think of it and go, I don't want to worry about overlapping IPs, right? That's step first function, to be able to just understand that. The second is to sort of look at what type of authentication authorization controls would I want, instead of just blindly relying on MTLS, for example. And that could be a heavy load on certificate management, et cetera. And then the last thing you want to think about is, how do I connect my north-south? So here's where I'm showing a very simple example of.
Can you just quickly explain sort of east-west traffic versus north-south traffic? Because I know, I mean, that's a networking term, but some developers may be like, okay.
Oh, east-west. Think of it as east-west, as in your microservices calling each other across VPCs and accounts. Purely lateral, nothing coming from the user, or you're not going after the internet. North-south is where your users are coming in. Like in this slide, I'm showing API gateway as an ingress, right? So you expose your API as a developer, and then that API is running, let's say, on the back end through a Lambda function. So in a purely serverless architecture like this, you could have API gateway, your users coming in, that is a north-south traffic. And then API gateway now has to invoke the Lambda, your function that's running in that Lambda, right? And let's say that's in a different account. So in this example, I'm showing how with Lattice, you can connect them all, and it's a purely serverless model where you have to have that Lambda that I'm showing in VPC1 that talks to Lattice, and then Lattice can route traffic to whatever the backends may be running. It could be serverless, it could be non-serverless as well.
Okay. Yeah, we do have a question from Schizophrenic Web Developer. Thanks for joining us via Twitch. Can we return some small static data direct from VPC Lattice without sending it to the target, like some robots to text content? Or is this just a networking construct that you would need to have something behind it that's actually going to serve it?
Yeah, no, that's a great question. So today we have a fixed response, right? So we give you a 404 or whatever you want for that particular service as a fixed response. We can totally add additional context there, like being able to send a particular response back in addition to just the 404 HTTP response, some text as a almost like a caching function is what you're alluding to. So we don't have that functionality today, but that's sort of what we can evolve to as well. So it's a fixed response today, but we can add more content.
Satish, maybe another thing to address though is typically, at least in the example in the chat, that's really a public use case. Maybe talk about kind of when Lattice is used, primarily privately versus where the north-south might play into the public domain as well.
I see. Yeah, that's a great point, Hiki. Yeah, thank you. So in the public domain, think of it as your users logging, accessing your APIs, right? That's the API gateway or ALB if you're non-serverless. But let's stick to API gateway, right? So typically you would enforce the user login, authentication authorization, OIDC, end user auth, et cetera. You already did that at the API gateway level. And then now you invoke the backend. Now, if the backend calls, this is where east-west traffic comes in, have to go across multiple microservices to fulfill that API call. So for like a website that's running, you have to go to payments, customer order, et cetera, that whole flow. Think of that as going over Lattice and then making sure that when a payment system calls inventory, that is already authenticated between Lattice, so nobody can spoof that. So Lattice gives you that additional security in addition to the north-south user-based authentication to make sure that that order, that whole flow across the microservices is authenticated and not spoofed. And this traceability, that's where we build observability, and it's zero trust. Tomorrow, if you say, hey, inventory should never be called by this other service, you put a policy on that inventory service and say, don't allow access from this service. And that's as simple as not having to, as a policy-based invocation and nothing involving networking. That's the key point.
Okay. So it's also, I think, in a way, moving from the port and socket security model where I know how it evolves, where everything lands up being on 443 or port 22 and everything having to connect to each other, to a more fine-grained IAM control, which is, I know, complex, but also infinitely scalable that, once you've got IAM set up, it is amazing what you can do with IAM. And yeah, you just have so much control of what can connect to each other without having to, think of ports and sockets.
That's right. Yeah. I think we have a question. This is about blue-green deployments.
Yeah. CS Dan Nitch, thanks for joining us via Twitch. Yeah. Is there a way to perform blue-green deployments for a target group with multiple listeners and rules?
It's possible. Depending on the use case, like I'm showing here, there's multiple rules, right, for one listener. So HTTPS listener with path-based, header-based, and a method-based routing. Here you could do, for that particular rule, let's say on that path-based rule, you can set up multiple target groups. That will be a blue-green for a path-based. You could also do the same thing for the header-based control as well. So there's flexibility here to do that, multiple rules, and the way we built Lattice is to sort of be able to scale as well. So if you need, for some customers, we've done 50 rules, for example. So they have 50 different Lambda paths. Each Lambda path is a developer stack, and then they go and handle concurrency and versioning on that Lambda stack for that particular path-based rule or a particular header-based rule.
Okay, I think there's a follow-up question around to the same target group, and I think this might have been the slide you had showed before.
I see. Yeah, so this one, it can't be the same target group. So a single target group is sort of addressing one set of targets, right? So your Lambda function, for example. So the blue-green would be across the two target groups, and the two target groups can point to different VPCs if you need them. They have to be in the same account, but you could do different VPCs as well.
Okay. Before we do get into the components, because that's see sort of listeners, rules, and target groups, it'd be good to sort of dive a bit into that. But some networking people also think, well, service meshes has been a big thing over the years. Obviously, some open standards with that, in the Kubernetes world as well, that is super important. How should people think about VPC Lattice compared to service meshes? And then the sort of follow-on question is there a story with on-prem as well where VPC Lattice can connect to on-prem services?
I see. Yeah, both. So for our service mesh, to answer that question, right? Service mesh is one use case for Lattice because it's not just Kubernetes focused. Even within Kubernetes, we also support Fargate, right? Which is what most customers want, serverless. But other open source service meshes are not supporting serverless today for all sorts of good reasons. And so when we built Lattice, we considered service mesh as one use case, as a microservice architecture for Kubernetes workloads. But we are also seeing customers do a lot of serverless service meshes as well, right? So that's where we built Lattice for, us to be able to say, if you want to take all of your microservices and make them all Lambdas, and we have a couple of customers doing that, and that could be your mesh connecting using Lattice. So nothing to do with Kubernetes. It's still a mesh, microservice architecture, north-south ingress with API gateway, and then going to all of your Lambda backends. And therefore, the concerns there will be like a service mesh. How do I enforce authentication authorization, connectivity, service discovery, right? And then lastly, observability, which is what we've built it into Lattice to be able to give you that detailed view. So to answer your question, Julian, yes, Lattice is built to address the service mesh as a use case for sure.
So if people have existing service meshes on Kubernetes, can they integrate with Lattice as well, or is it a sort of either or? How would somebody think about that when this sounds all great and they're like, but I maybe have some service mesh functionality already?
Right. Yeah, but that's where we build Lattice to be non-invasive. So if you have an existing service mesh, whatever the flavor might be, Istio, Linkerd, Console, your favorite ones, and you're deploying that already in a VPC, and especially if you're going to a multi-cluster architecture, where you have multiple clusters in separate VPCs, but you need to connect them together, right? And that's where you can still have your service mesh running in that VPC, but you can use Lattice to connect across all the ingress gateways, for example. And one common and popular use case that we see a lot is to take an existing service mesh and be able to have that call a serverless function, like Lambda, or other services running on Fargate. That's where Lattice comes in and sort of gives you that all compute flavors are equal. Therefore, you could be running Istio in a single VPC, in a single account, and then talk to Lambdas and Fargates in other accounts, other compute types.
Okay, I like the concept of a non-intrusive network. I think you said the VPC Lattice is non-intrusive. I like that as well. Yeah, just schizophrenic developer again. Yeah, does Lattice support WebSockets?
Yes, yeah. So you can have Lattice, the multiple listeners in Lattice, HTTP, HTTPS. We also added TLS pass-through. So if you want to do MTLS on your own, you could set Lattice up in TLS pass-through. We won't break open the TLS connection. In that mode, you can have WebSockets that are talking to each other. We also added native support for TCP. So where Lattice is not a proxy, and your client and your server can be connecting over WebSockets, and then you can have enforce the timeouts or unlimited time that you connection duration time based on your needs. So the both options possible for WebSockets.
Excellent. Well, I mean, how many questions are we having? And VPC Lattice seems to do them all. So yeah, I'm impressed with the lattice of connectivity. It's cool. So what do we want to go on? What do we want to go on to next? I mean,
I want to share. Thank you, Julian. I want to share this one use case for private integrations as well, right? This is a common use case that's evolving. The new functionality that we just announced at reInvent before, and you might have seen Jeff Barr's blog, sort of talking about event bridge and step functions, being able to invoke TCP databases directly or DNS servers directly, right? So here I'm showing an example of private integrations without proxies where there's a Bedrock API that's being called here in this step, in this step. And then that's invoking a function that's running on Fargate today. And in this example, I'm showing the Clarify server is sort of using that step function to do an HTTP endpoint call through event bridge connections. And then you're setting up Lattice to sort of connect an event bridge connection to a backend resource config that is the ALB today. And so look at this. There's no, across the two accounts, there's no other networking needed. You specify the ALB's DNS name as a resource, and you add it to Lattice in the service network. And then we connect the Lambda function invoking directly to that ALB over Lattice. So you have that easy way of not having to use proxies or other Lambda functions you had to use before, right, to connect from event bridge and step functions to any other private APIs. So this is a very popular use case that's evolving, being able to use Lattice as well.
Okay, so this is the step function of an event bridge, very serverless services. They can now reach into VPCs, same account or cross account, and that's actually using VPC Lattice under the hood to do all of this. So in a way, where AWS is building on its own services and using Lattice as the sort of simplified but powerful networking construct.
That's right. And then here, we plan to enhance this further by adding policies, just like I showed you auth policies across services, right? Layer 7 services. We're going to add services to auth policies for what we call resources, TCP services or DNS services, where you can control access from a VPC, an account, et cetera, going forward as well. So we give you that same flavor of service-to-service authentication or call-to-call authentication, microservice-to-microservice authorization policies as well.
Okay.
And I think we have spoken enough about theory. Maybe we should let Hiki actually show us how this all this works.
This all connects.
Yeah.
Sure, happy to do so. So let me just share a quick architecture diagram, just so we have a visual of what we're going to kind of walk through. See if we can get that pulled up.
Oops, I removed Higgy.
Oh, can you guys?
Sorry, Higgy, I removed you from the screen instead of the. There we go.
So I know there's a lot on here, but one thing that Satish had mentioned in one of his earlier slides was this consistency across compute services. And I'm a pretty avid serverless guy. And so sometimes I'm like, ooh, Kubernetes, no thank you. But one thing that's really nice about what Lattice does here is, like I was saying before, is it allows us to kind of be one big happy family, right? So, and if we kind of apply some of the north, south, east, west type of communication that Satish was talking about before, if we look at the top, we have your client. So maybe this is some web browser, or maybe this is a crawl client. The north-south ingress is going to be through API gateway. So we're going to use a regional REST API endpoint. And of course, we're going to have Cognito auth to make sure that all these requests are authenticated and authorized. We're going to use a Lambda function in here. And that's really the end of the north-south piece of it. I'm using that Lambda function up top in the 6179 account in green. That's going to kind of be my client into my VPC Lattice network. Then if you look on the bottom, this is really that east-west. So all of the purple boxes, so the Lambda function as the client. Now you see on the bottom, there's essentially 3 API microservices. There's one that's built into Lambda. There's one that's exposed in Fargate. And then there's another that's exposed in Kubernetes. And so as part of the demo, what we'll do here is we're going to actually make a very simple GET request against each of these backend APIs. And the way that we're going to validate this, now you have to take my word for it. This is not just me mocking a response and just faking you all out. But if you'll believe me here, I've deployed them into 3 different accounts. So you'll see VPC in account 4753, et cetera. And the way that we're going to verify this is that way on the bottom, you'll see in green, I have the name of a DynamoDB table, right? And so you could imagine with my microservice architecture, I've written some code. I've also deployed a database associated with that, which we're going to use Dynamo for. So when we make these API requests, we're gonna authenticate with Cognito. We'll make a validated call. Lambda will then proxy it into the VPC Lattice service network, and then we'll make a call respectively based on our JSON payload, which I'll demonstrate in the next slide. So okay. Hopefully that makes sense. If you all have questions, please do ask, because I know this can be a lot. This is the event payload, or the request payload we're going to use for our calls. And so essentially what we're going to do is we're going to just say, I want to direct my request either to Lambda, ECS, or EKS, as I was showing in before. And one thing that Satish had also mentioned was about some of the security policy. I'm not going to go super deep on the security side, But one thing that I do want to demonstrate is that we can require SigV4 signing for requests coming into VPC Lattice. This way we are assured that there are no anonymous calls being made throughout the network. So because it is SigV4 signed, we know that you have the correct authorization to make this call. So what we'll do is we'll start with making a call to each of the endpoints. We will turn SigV4 on and we'll get successful requests, hopefully to each of these DynamoDB tables on the bottom. And then what we'll do is we'll just do a quick example where we turn off SigV4 signing and hopefully we get a 403 permission denied error. I'll do that quick demo, and then if we have time, I could actually go into the console and show some of the logs and things that Satish was talking about from an observability standpoint.
So those three Lambda, ECS, and EKS, those are obviously different DNS entries, and then the Lattice network is basically going to resolve that DNS entry, send you, which resolves to a port in a socket, and ultimately you're going to then connect over there. Okay.
Yeah, and the other nice thing that I did here is with VPC Lattice, you can also associate an ACM certificate to them, and then put an alias on top of it. So in each of these, I think I have, again, if you look at the request payload, I'm actually not using the Lattice service name. I'm just using Lambda ECS EKS .internal, again, internal to kind of demonstrate that it's actually an internal network. And we actually have a private certificate associated with each of those.
Okay, yeah.
Okay, cool. So bear with me. I know switching screens is a little bit jarring, but I'll bring up VS Code and we'll do a couple of quick things. All right, so here we have our terminal shell. This again is that event payload or the request, the post body, and we'll take a quick look. So I'm a big fan of make files, and so I'm just going to use these make commands. You'll see
how many make files do you have on your laptop?
Too many. Every project has an individual.
You're the king of make files, I know, which is awesome.
So I've done a bunch here, and I'll explain what's happening here. The first thing here is I'm essentially authenticating with Cognito, right? So I'm just basically initiating auth. And again, because these are all credentials and tokens, I'm just hiding this off from you. But this is essentially my ID token, access token, refresh token. And I write that to a local file. I could have exposed my ID token to you, but again, I need to create the header. So what I've done is I just written that to a headers.txt file. This way, this is basically the authorization header with my token. And then I'm going to do a post against that with my headers. This is that file that I just created here. So we're saying, let's go talk to Lambda, and we're going to enable SigV4 off.
We did have a question, schizophrenic web developer, just talking about that auth flow. So, and this was, before discussing the architecture. So API Gateway does have the possibility to check the JWT token, if valid or not, and that is issued from Cognito.
That's right.
And that's a sort of yes-ish, but it's not API. It's not API Gateway itself that's actually checking it, isn't it? A Lambda authorizer that is doing the checking on behalf of API Gateway. Is that correct?
Yeah. In this scenario, I'm actually just doing it direct to Cognito.
Okay.
This is using
a direct integration
authorizer, right? So I have no custom code in this scenario. Okay. I basically so you'll see here I'm actually making an API call to the Cognito endpoint, and I'm basically saying initiate auth, give me my tokens. I extract. In this case, I'm actually using the ID token. And then I'm including that as part of my authorization header. And Anton's this is where we're gonna get into the AI world where AI is gonna start replacing me with make files. So as we were saying before, again, if you'll believe me, I made this request. I hit essentially the Lambda backend, and it responded back with the name of my my DynamoDB table in that Lambda microservice. So I'll just go through this quickly. Again, there's nothing magical here. I'm basically saying I'm going to direct this request now to my ECS backend. And again, if you'll believe me, these are actually deployed in separate accounts. I've now hit that ECS backend. One of the nice things here is as a developer, now it's just any API that's available to me. I'm none the wiser that this actually happens to be in a different account, which is really great as an API developer. And then again, last but not least, let's do the EKS call. Where it'll make that call back to the ECS backend. So one thing we'll show again here is this all requires SigV4 off. So what I can do here is I'm going to actually turn SigV4 off on. So basically in that Lambda client, I just check for this value. And if I don't have this value, I'm going to attempt to make a request into the VPC Lattice service network without signing my requests. And so I would expect I'm trying to hit the EKS backend. Something didn't go right. Let's do this to the Lambda one. Something, of course, the demo gods are messing with me. Yeah, so this is what I would have expected even on the EKS one. Not sure what happened there, but this is what I would expect because I didn't sign the request. It was then forbidden. Any questions on that one? What I'll do real quick, Julian, did you have something you want to interject?
Well, no, it was just a comment that the demo looks so simple, but you are literally here reaching from a source through API gateway to a Lambda function that is then proxying it to one of 3 different accounts. But the API calls to exactly the same place. The whole curl command's exactly the same. And yeah, it looks simple that you're returning, but you are now connecting to 3 different databases in 3 different accounts. So I think the demo is hides all the complexity, which is is the point, I suppose. But this is understanding how much power is happening behind the scenes.
Yeah, to your point, I think this is a really big separation of concerns type of thing. So maybe maybe Julian and myself were the application developers, we're the line of business developers. Satish, you kind of represent the networking platform engineering team. So you would vend to us these capabilities, and then as a developer, I don't have to worry about that anymore. So this is where it's really nice around the platform engineering team or the networking team provides us these constructs and gives us this ability to talk across all these accounts.
Cool. That's exactly right. Yeah. So imagine me creating that service network and connecting the 3 different accounts or 4 different accounts. And then you as a developer on the Lambda function, ECS, EKS, and the API gateway, provisioning them and then being able to just connect over and enforcing that auth, like the one that he just turned off and got a deny response of 403. And that's the policy that's on Lattice to say, hey, if it's not signed, you're not going to forward the request to the target and deny it right there.
You know what? I realized, I think on the EKS side, yesterday I was refreshing this environment and I was redeploying all my certificates. I suspect I didn't enable the auth policy on the EKS one. That's probably why that one went through. So my apologies on that.
I knew that would have been bugging you, Higgy. I knew you were sitting there,
that should not have happened. Let me also, again, I'll do one last context switch. I'll go into the console and I'll just show a little bit of how some of this Lattice stuff is working.
While we switch over, just Lundi's Elisa Silolo, how does this work with Systems Manager? I'm not sure if that's too much of an open-ended question. Maybe Lundi, you want to just mention what part of Systems Manager? But Satish, do you have any sort of high-level comments?
We're transparent to that. So depending on what you're doing with the Systems Manager, allocating certificates, et cetera, and managing the instances on your own, that is transparent to Lattice. Lattice is its own entity, being able to add anything on top of what you're already doing with Systems Manager.
Okay. Well, Lundi, if you have more details, and send it on. We'll be happy to answer. So we're in the console. I can see we're in VPC and we're in Lattice. So that's sort of the mental model of where we're sitting in the console.
So one of the things that Satish really pointed out here is this is the service network that's going to be shared across all of my accounts. So under the hood, what VPC Lattice will do is it's actually going to use Resource Access Manager, RAM, to share this across accounts. So essentially, this service network is visible. If you remember that architecture diagram I had, it was that Lambda client and then those 3 backends in essentially 4 different VPCs and in 4 different accounts. So this service network via RAM is shared across all of those different accounts. The next thing I'll show is this service association. So again, if you remember, it's down here. If you remember on the bottom of that architecture diagram, I had essentially the Lambda service, the ECS service, and then the EKS service. Those are the services that then get associated into my service network. And that's these 3 services. So if you look here, this is the full VPC Lattice name. And then here is that custom domain name. This is that certificate that I applied that makes it easier for me to then go and use those different endpoints. So what happens is so the developer will build and deploy the Lambda function, the ECS task, or the EKS pod. That then gets attached as a Lattice service or deployed as a Lattice service. That Lattice service then gets associated into the service network. Hopefully that made sense. And then the last thing I'll show is this. Again, this is an example of the Lambda service. So again, I only see a single service in this account. And I think this is, again, so you see the certificate here. This is that Lambda service. Again, this kind of demonstrates this is a single account, has only one of those services available to it. So I've associated that custom domain name along with that certificate. You'll see that I just refreshed the certificates. And then the thing that I think Satish talked about before was around the monitoring. So you can go over to the monitoring tab. I can click on this CloudWatch log group. And it is, again, I'm in Eastern, so 2:45 p.m. If I go to this log stream, so it was a few minutes ago that I did make that. Actually, let me refresh that. I would have thought it would have been sooner, but I'll just give an example. Okay, so 2:40. So 2:40 my time. This is an example of one of those logs into the service network. So this was that one that was denied. So here was the one where I did not sign the request. Therefore, it came in as a anonymous request. And I think, yeah, so we see the 403 denied request. If I go back, I should be able to go to, actually, sorry, let me click to that log stream and go to the entry right above it. This one had a resolved user of that Lambda client, if you remember. So because I SIG-v4 signed that request, it actually has the identity of the IAM role or the execution role of that Lambda function. And then if we scroll down, we'll see that we have a 200 success, right? So this is a demonstration of VPC Lattice enforcing security and making sure that it knows the identities making the requests coming into that network.
And logging that as well, so you could
Right.
have whatever your normal processes for looking for things or logs and looking for that denied and maybe taking action on it.
That's
Yeah,
right.
and to add to that, this troubleshooting is vastly simplified. So in the example where I'm the network team, I'm provisioned the service network, right? I get these logs for every request that, like in the example case, 3 different services that are calling each other. Okay, but Hiki, as a developer of the Lambda function, will also get his set of logs that are specific to his service. So he'll see the exact same data for his service. And so it's easy for Hiki to go and say, hey, what's my latency right now? Which services are talking to me? Which ones are failed? So this is where developers, you have a lot more information now, and they don't have to go to raise a ticket with networking teams or go and figure out, hey, what's my latency from this service to my service? We give you the logs separately for each service for yourself as well, in addition to the overall service network logs that give you that comprehensive view. So it's very easy for troubleshooting, understanding how your service is behaving, how many HTTP errors are happening, like different error codes, HTTP error codes. We give you that target group level metrics in both CloudWatch, and we also have these logs available to you in Kinesis Firehose. So if you ingest your service logs into like your APM, like Splunk or New Relic, Datadog, et cetera, it gives you a very quick view of to say, hey, what your service is doing, how is it behaving, what the latency is like, how many bytes have transferred, all the detailed information that, again, networking is abstracted for you, right? That's what we're trying to do here to make it easier for developers.
And I think we would be remiss if we didn't play our keyword bingo here and mention generative AI, right? So the idea here, because these logs are here, you could imagine bringing these in, like, again, Q operational insights. We could actually then use natural language to query these logs and try to get some insight into some of those root cause analysis as well.
Cool. And something I was thinking about from the sort of operational perspective is there anything that you can do wrong even to set this up? Because I know we've got, VPC Analyzer, and we've got, a whole bunch of networking constructs that I know network people use to make sure that things can get to each other. Is that abstracted away with this, or is there a way from a networking team's perspective to go, something is wrong, or someone's removed a VPC, or something's missing off a port, or what does it look like from a networking team when things are maybe not set up or things are broken?
I see. Yeah. So these are complementary to the network analyzer, network reachability analyzer, or connectivity analyzer. That level of view, right? That gives you the layer 3 level flow across the VPCs and accounts. So that's there for you. In addition to that, if you don't want to use them and just rely on Lattice, right, which is a way to say, hey, look, all my VPCs and accounts are connected over Lattice. And then at the service network level, you turn on logging, right? Then we send it to S3, to CloudWatch, or to Kinesis Firehose, and then you can ingest these logs. And I know we made it 48 minutes before mentioning Gen AI in this session, But like Hiki was saying, you could go ingest those logs into GenAI and gives you that detailed visibility, right? So this is where you don't just have to rely on the other network level analyzers, reachability analyzer, et cetera. This gives you that additional view and every request, right? So this is also good for security auditing, for example. If you need to enforce a compliance policy and say, hey, is my network compliant today? And you could ingest these logs, put it into a SIAM that is GenAI friendly and say, am I compliant today based on the traffic that I see on this network, on the service network?
One other thing that I would say is a big difference. Again, I was a network engineer over a decade ago prior to this. So again, my skills in this area are probably dated. But one thing that I would say is a big difference is, for example, I know a lot of enterprise customers are using Transit Gateway as an example for integrating VPCs across many different accounts. And that Transit Gateway then needs to take into account all of the routing rules, right? To know which VPC is allowed to route to which one. One nice thing here is with VPC Lattice, if you're within an AWS organization, you just use RAM to then be able to share access across all these different VPCs. And it greatly simplifies the ability for us to then extend across different VPCs and then to be able to then access different microservices. What I would say is there is then a trade-off. In the networking world, a lot of it was really around routing rules. Now here we have to think about all of the policies that we want to then apply as services communicate across each other. So I think there's simplicity in some areas, but there is some, let's say, additional legwork you need to do from a security standpoint, because we don't want to just open this up and kind of make some of our services vulnerable, even to east-west traffic. So there's a balancing and trade-off in how we're deploying this.
Yeah, that's a good point, Hiki. And then a simplified JSON-based policy, being able to put at the service level and at the service network level, right? That gives you additional defense in-depth controls across different dimensions, right? And the revocation is a lot simpler. So today, if you have to go revoke access to a particular service on the network side, most customers have to go set up change a firewall rule. And we all know how hard it is to change an existing set of ACLs and firewall rules, right? So whereas in Lattice, we made it easier by being able to just change the policy at the service network level or the service level. And then as soon as that policy takes effect, the rest of the traffic will be enforced with that new policy. So revocation operationally, to your point, Julian, becomes a lot simpler, both for security people and developers working together.
Yeah, nobody's risking deleting firewall rules just in case they build up and build up and build up. So I think your 10 years ago, Higgy, that's exactly the world I was in. Yeah, I hear you. Lundi just did come back about the parameter store question: secure parameter storage, instance management, and SSM agents in managing the configurations in the Lattice networking. The cool automating documents within the Lattice document. But I'm sorted now. Thanks. So, well, Lundi, there we go. Thank you very much. And a schizophrenic web developer, of course, GenAI can make mistakes. Not smart to give this logs to GenAI. Well, depends what you're going to use them for. I certainly wouldn't necessarily trust your life and your CISO's hat on only using GenAI, but if it's going to be quick and helpful, then go for it. If not, try something else. So what else have we sort of not covered today, or what's top of mind, Satish or Higgy, that would be interesting? And even some tips or tricks for people to keep the simplicity. We're talking about simplifying serverless networking. Any issues or things people should avoid, or things people should go for when they're exploring VPC Lattice.
Let me start with one simple one, and then maybe Satish can kind of wrap us. Like, one thing that I would say, and Julian, this maybe goes to your earlier question. Again, I'm coming more from the serverless side than the networking side. I kind of represent both. I would say start simple and build as you grow in requirements, right? And so, like, if I have let's say an API gateway with Lambda and DynamoDB stack, and I don't really have private networking needs, candidly, I would say, like, Lattice is not something that you should have in that situation. Let's keep it simple. If you start to grow in needs where I need to, even if it's just within the same account, I have a Lambda function that needs to access an RDS database. Again, in that scenario, I would still say you probably don't need Lattice. You just need RDS proxy and do some good connectivity there. I would say if you start to get into scenarios where we now have multi-account deployments and we want to be able to talk to a lot of different compute platforms as if they're the same, this is where I would start to think about this could be a potential solution. So again, I don't want to necessarily say Lattice is the hammer for every networking challenge that you have in a serverless space. It does make sense in certain scenarios, but let's not jump there as the first thing.
Yeah, that makes sense. And just to piggyback off that, yeah, that makes complete sense. And yeah, don't over-plan your network. Even in traditional networks, over-planning your network up front in some scenarios can cause you pain. But when you're building a VPC lattice network, is it seen as one network with many thousands of nodes or resources or things you can connect to, or do you need to subdivide your VPC lattice kind of things? I was thinking there, you had your northwest traffic, your north-south traffic going from your API gateway to your Lambda, and then using lattice to go east-west. If those, for example, you weren't using DynamoDB and maybe you were using another database that was in another VPC, for example, would you have another then VPC lattice network connection, or would it? How does that work? Is it one VPC lattice to rule them all with lots of different connections, or is there any way you need to segregate your VPC lattice setup?
Yeah, that's a great question. Microsegmentation is another popular use case as well. So think of the lattice service network as a grouping mechanism, right? And so typically customers deploy a staging prod, non-prod type of service networks, one per environment. So that way you can enforce different policies because each environment has different needs. A single service can belong to multiple service networks. So you can add a shared service into prod, non-prod, and staging, all three at the same time, and it's available to all three service networks. So, Julian, to your question, think of the lattice construct as use service networks as many as you need to, right? One per environment is a typical deployment middle ground. At the very extremes, you can have every VPC connected to its own service network. On the other extreme, you can have one single service network that has everything in it. But there are trade-offs, right? Like with everything in life, it's someplace in the middle is probably the best answer. So it trade-off in the number of policies, entities, degree of control, et cetera. So most customers typically deploy one service network per environment. Prod, staging, UAT, and then control access within that separately. And then we also added additional features, like we added support for TCP. And so our goal with service networks is to be able to have your serverless workloads in there, your layer 4, layer 7, whether they're serverless or server-based, and then also add AWS services. We added RDS as the first one, as a native integration. So RDS will be available natively in that service network for anything that's connected to that service network to invoke. And then we're going to add more AWS services in there. So our goal here is to sort of give you that service network as a way to sort of group all of your services and AWS services together in region and also cross region. That's sort of what
Perfect.
we are evolving towards.
Thank you. We only have a few seconds left, but Anil, a great question here. How do you see VPC lattice? How does it work with VPC endpoint services, or are they complementary?
Yeah, the new endpoints that we just added are complementary, as in the service network endpoint and the resource endpoint talk to Lattice Service Network. And the reason we did that is to sort of give private link customers, who Anil seems like being very familiar with private link and endpoint services, right? Today you have to spin up a single endpoint for every service, right? It's one-to-one. With Lattice, what we've done is sort of give you a single endpoint. The new endpoint's called Service Network Endpoint. That gives you access to multiple layer 4, layer 7 services, and your endpoint services can be through DNS or through ARN, like RDS is the first one, right? So this is where we have built it that way to give you that flexibility.
Excellent. So this is for your own private resources, a VPC endpoint for talking maybe back to Lambda, or talking back to S3 or Secrets Manager or that kind of thing wouldn't necessarily be the same kind of thing.
Satish, I'm curious, I know we don't have that much time. Can you inject your own custom headers in there when you're making the requests via that connection? When you have that connection to a VPC endpoint service.
I see.
You've got I didn't know about that, so now I'm thinking of a particular use case, and we could probably talk about that.
I see. Yeah. So header injection, something outside Lattice has to do that today.
I see.
Like a proxy or something. That's what north-south ingress.
Well, it was 59 minutes when we found something that Lattice doesn't need to. Time is up, Satish, Shiki. That was phenomenal. So much interesting stuff about networking, a whole new world of, I think, possibility. And I think there's only going to be more being added, especially with the service endpoints. I'm excited. So thank you very much. See everybody same time, same place next week. We'll be talking PHP on Lambda with 1 billion invokes with a serverless hero. So thank you very much today.
Thank you.
Bye-bye.
Thank you, everyone.